right, welcome to chapter 3. We're talking about linear equations and functions. This is stuff that you guys have seen before. This is y equals mx plus b, standard form, all that fun stuff, slope. Coordinate planes, x and y, all sorts of things that I'm positive that you have studied before. We're going to review it here just to make sure that everything's on track before we move into a little bit more complicated work. So if you can follow along in your book, I'm starting on page 101. I'm going to go through a couple of examples and then set you off to do some work, practice problems on your own. Okay, so this first example is just giving us an equation in standard form. Remember, standard is where you have a coefficient, then x plus a coefficient, then y equals c, right? ax plus by equals c. Okay, in order to, and then they give us a domain here, which is basically anything that can be plugged in for x. Okay. Also, I read this as x belongs to the set of -1, 0, 1, 2, 3. This little funky looking e, it almost looks like a euro sign, but with only one line through the middle, it means belongs to. Okay. So what I'm going to do is first, I'm going to solve this thing for y so that when I plug in x, I just automatically will get out a value for y. I'm also going to use a chart to organize my work. You don't have to use the chart, but it's kind of nice to just keep everything in order. I can see the beginning and the end all in one line. Okay, so just subtracted 9 from each side, divided by 2. You'll notice that here I wrote it as -9x, just so that I can start to see that slope, -9/2. But over here in the final form, I wrote it as 15 minus 9x, which is just the commutative property. You just flip them around. It's mostly so that I chose to flip the order just so that I wouldn't lose this negative sign. Sometimes if it's hanging out at the beginning of a problem, I'll drop it. I'll forget that it's there. So if I put it as subtraction in the middle, I'll remember to keep it around. Okay, so what I've done here is I have built this chart where I took all of the domain and I put it in this first column here. So you'll notice we got x labeled, then -1, 0, 1, 2, and 3, which are the same values as over there. In this second column, I took what y equals, so just the right-hand side of the equation, and I put it in this column here, 15 minus 9x over 2. And in each place underneath, I just substituted it in whatever the x value is for that row. I placed it in to the equation here, right? Now what we're going to do is just crunch some numbers, keep track of what the y is, and then look at what the solution might be. All right, after doing some fancy simplification using PEMDAS, an order of operations, I found that when I plug in -1, I get a 12. So my solution is actually going to look like this ordered pair where I place the x value first and then the y value after. So what this means is that when I plug in 1 into my equation, I get 12 out. So this solution set, this pattern, is going to go all the way down. These are called coordinate pairs, and they give us the x and y value that we'd plot on a graph. Okay, so just filling in using that pattern, I see that when I plug in a 0 into my equation, I get a 15 halves out, 15 halves, which is 7.5. And plug in a 1, and I get a 3 out. Plug in a 2, and I get a -3 halves out, or a -1/2. And plug in a 3, and I get a -6 out. So my solution for this entire problem is going to be these ordered pairs. So what I could do next, and what I'll be doing in the next section actually, is graphing these ordered pairs and then drawing a line through the graph, and that will give me what this function here looks like, which is the same as this function here. Now I'm going to flip into the practice problems. I'm looking at page 105. In this top section here, it says find the value of k so that the ordered pair satisfies the equation. So they give us an equation here, 3x minus y equals k, and then they give us an ordered pair. And they want us to find the value of k so that this ordered pair makes the equation true. So what I'm going to notice is that For here, this value is just x. This value is just y. So I'm going to plug those in for x and y here. So plugging in, doing a little color coding, I've got the 1 in for x, the y, or the -3 in for y. Then I'm just going to simplify, and that will give me this k value. So I find, after simplification, I find that 6 equals k. Now the way that we'll use this eventually, right now this simply answers the question right here, 6 equals k. But what we're eventually going to be using this for is to determine how we're going to rewrite this original linear function in standard form. So I'm just going to copy everything, 3x minus y, but now instead of writing k, I'm going to write that 6 equals 6. So this would be my new standard form of this equation such that this ordered pair satisfies this equation.